Hi guys, welcome to the Decision Tree and Random Forest project solution lecture. I'm sure you have already dealt with all the tasks by yourself. Let's move on and try to solve all the tasks together step by step. So the first thing he is asking for to import the required libraries. So let's run this cell here and we are done with all these imports. Read the CSV data file and display the head. So df equal to pd dot read CSV and the file name is memographic masses data clean.csv, and let's display the head of our data frame in the same cell. Run this cell and here you have the head of your data frame. The last column is target, so you have the same output. The next one is how many data entries you have. So he's simply calling info on the data frame df. So df dot info, and here we have the same output. We have 830 entries in our dataset. So the next one is which type of cancer is common. So you can grab the target column and call the value count there. So df target dot value underscore counts and run this cell, and we have 427 type 0 and 403 type 1. The next one is reproduce the output to show some statistics. Very simple task again, df dot describe, and we get the same results what he's asking for. So the next question is reproduce the plot below. You see that you have a count plot here and target is along x-axis. So we can call cbonds count plot sns dot count plot, and our x is target and our data is df, and let's run this cell. We have the similar output. The only thing is the color scheme is different, and this color scheme is cool warm. So let's pass in Pele here as well. PALETTE is cool warm. So let's rerun this cell, and here we have the same output. We have the same plot. So the next one is recreate the plot below. If you notice that he's putting two histograms on the same canvas. Another thing you notice that he's grabbing the age column based on the condition on the target column. So he's applying condition where target is equal to 1, which is malignant, and target equal to 0, which is benign, and then grabbing age column. Let's create a canvas first, plt dot figure, and pass in fig size equal to 10 and 6, and then df grab the target column is 1 for malignant, and this is our masking condition. Grabbing age column based on the masking condition on target column, and then calling histogram here. Let's run this cell, and here we have the histogram where age is along x-axis and the values we are grabbing are only malignant from our data frame. So to get the same output, we need to pass in few other parameters like color equal to, so for malignant it's blue, bin size is different, let's pass in 30, and label is, his passing label is malignant. Let's rerun this cell, and here we have a similar output, like we have the similar histogram, the color is different. So he's using alpha as well. Let's pass in alpha here, equal to 0.5, and rerun this cell. So now we have the similar color for the malignant. So part of plot is already there. The second one, which is orange, is a condition where target is equal to 0 for benign. So let's copy this line and paste it here. And instead of 1, we need to pass in condition where target equal to 0. And our color is red. It looked like orange, but it's red, but he is passing the alpha. So red, bin size is again 30. Instead of malignant, it is benign, and alpha is 0.5. Let's rerun this cell, and here we have the similar plot. The only difference is we need to pass in X label as well, and then display the legend as well. Let's split this code. This is getting longer so that you can see what the code is. So now we have this code for blue plot, and we have this code for the red plot. Let's set the X label age, so plt dot X label age, and then display the legends plt dot legend, and let's run this cell. And now we have the same output. So once again, plt dot figure, then we are applying condition on target column for malignant where target equal to 1, and grabbing the age column and calling histogram. Then we are passing a couple of arguments or parameters to get the plot similar to the output what he is asking for. In the second line of code here, we are grabbing target column based on condition where target is equal to 0 for benign, and then grabbing age column and calling histogram. And then we are again passing a couple of arguments to get the similar plot. Then we are adding X label and displaying the legend. So the next one is do the train test split using test size 0.3 and random states default values. So the default value for random state is 42. Let's do the import here from Scikit-learn dot model selection import train test split. Let's run this cell here. To do train test split, we have to separate features and the target values. Let's separate them. So X is equal to df dot drop, pass in target. This is what we don't want in the features, and axis is 1, and our y is df and target. Let's run this cell, and we have separated features in X and target values in Y. Now we need to do the split here. I will press Shift Tab and copy the code just to save some typing. Here we have the code. Let's delete these dots and split this into 2 lines. Test size he's asking for 0.3 and the random states, which is the default value. Let's run this cell to do the split, and now we have train and test datasets. The next one he's asking for to import decision tree classifier and create its instance. In the previous lecture, we have learned that the decision tree classifier is under tree actually. So from Scikit-learn.tree import decision tree classifier, and let's create its instance in the same cell, which is d3 equal to decision tree classifier, and then we are not passing any parameter here. We are using the default parameters. Let's run this cell, And now we have created an instance for our decision tree classifier, which is D3. Fit the training data to the model. So we have the training data set in X-train and Y-train. Let's train our model. D3.fit and pass in X-train, Y-train and run this cell. And here we have trained our model using training dataset and default parameters. Do the predictions for the test data and print the results. So let's get the predictions here. Predictions equal to D3 dot predict and pass in X test and run this cell. There's no error. We got predictions from our model in predictions variable. Let's do the import again for classification report and confusion matrix from Scikit-learn dot matrix import classification report and confusion matrix and run this cell. Let's print the results. Classification report, we need to pass in the observed values which are in Y test and the predictions, and then print confusion matrix and again pass in Y test and predictions and run this cell. Our results are slightly different here. We passed in random state 42, but if you check in the solution notebook, the random state is actually 101. So these results are from random state equal to 101. Anyhow, it doesn't matter. You can change the random state and see how the results are changing. So moving forward with the random forest, import random forest classifier and create an instance. Let's do import for random forest classifier here. So from Scikit-learn dot ensemble import random forest classifier and then create its instance RFC random forest classifier with 200 number of trees. So n estimators equal to 200 and run this cell. So the next one is fit your training data to random forest instance. So rfc.fit pass in xtrain ytrain and run this cell. And here we have trained our random forest classifier. Do the predictions. So pred equal to rfc dot predict and pass in x test and run this cell. There is no error, so the code is working. And now print classification report and confusion matrix. So print classification report, pass in y test and pred, and then print confusion matrix, pass in y test and pred. Once again, you will see that the results would be different because we are using the same train test split here. Our random state is same what we did for the decision tree. So let's run this cell and we see we have 0.78 where the output was 0.79. Just to remind you again, these results are by using random state equal to 101 while doing the train test split. Whereas in this lecture, we have used random state equal to 42. You can change random state equal to 101 and repeat all these tasks, and you will see that you are going to get the same results. The last question he's asking for, which model is better? We see our results are improved when we are using random forest classifier. Once again, just to remind you, the random forests classifier overshines when you have a larger amount of data. So guys, This was all about decision trees and random forests. I hope that you are enjoying machine learning section. Once again, I recommend you guys to go through these lectures again, try to understand each and every step, and if you have any question, just post in question and answer forum. I am always there to help you and answer those questions. See you in the next lecture where we are going to learn another machine learning algorithm. Good luck.